G'day guys. Well, I've gone out, I've done some testing, I've come back here and I had to chop up some big trees out the front. Well, one tree in particular, it decided to drop a big branch on our power lines to the house and nearly took them out. So I've been up the tree cutting branches and making them smaller so they fit in the bin. And I got a fellow who happens to be one of my sons who's got a gardening business. So coming here tomorrow morning to pick it all up and take it off wherever they take it to. So yeah, I had a good day. I did a bit of travelling around. I went around the Canadian forest and the Aboriginal place, which is, I don't know how to pronounce it, Warung something or other. Yeah, and anyway, I just did the video testing the wireless audio system, which will be the video before this, I hope, so I get it around the right way. And I've just poured myself what they call Fireball whiskey and sugar-free Coke, and I deserve it. I really do. I've had some interesting things, like, you know, the saw hit my fingers. I don't know if you can even see that, the two lines there on that finger. I'm not giving everyone the finger, I'm just showing you my finger with the cuts on it. And then coming down the ladder of the tree, I dragged the saw across my leg like a complete idiot. And I've got three band-aids there holding it together. So yeah, that's been fun. So I'll drink to that. Anyway, because I've been detecting and doing detector electronics, detecting since 1980, doing detector electronics 1990 osh, not 90 odd, around about. So it's a long time, and I can, no, do I say it? Yes, I will. Hang on a sec, I need another sip before I say anything. There's another detector coming out. And I have never seen anything like it before. This is going to be the new king of detectors. I know back in 2015, I did an article and we had an advertisement in the Gold, Gem and Treasure magazine for a detector we were working on at the time, and it was going to be light years ahead, even in 2015. And there were some problems with that project, and we put that to bed. But it's quite funny, everyone has tried to pass off on our advertising and call their detector the ultimate detector. So I'm not going to say what the next detector will be, because we don't want anyone passing off on that. But next time round, we'll put some protections in place. So that'll be one thing. But I can tell you right now, the performance level of this new gold machine, right, is completely out of the box, outside of the square, outside of the circle. It is going to be a marriage of two technologies, and it's absolutely going to be an absolute ripper. I wouldn't estimate it that it's going to come out anytime real soon. I would say maybe towards the end of the year. I'll keep updates on it. I know the people involved, and I will keep everyone informed on this. This is, I would say, this is the leap. It's equivalent as a leap from VLF to pulse induction. When the SD2000 first came out, it was absolutely mind-blowing, the difference and the depth that could be obtained on real large gold. And you know, when you really look at it, the detector designs across the board, from no matter who the manufacturers are, within reason, they've all concentrated on finding very, very small gold. The reason being, and this is just to make this is how we'll call it the advertising department spin, right? We'll just keep the punters happy. If they find a few pinheads, they will be happy, rather than finding nothing, right? This is how it works. So you got all these detectors out there that, you know, in my opinion, right? I always say in my opinion, because you're legally protected by Geneva Conventions to have an opinion. It's a fundamental human right. So my opinion is that depth is sacrificed for bigger gold to find smaller, shallower gold. And you know, no one's going to find the life-changing nugget using that technology unless they're going on very, very new ground and it's very close to the surface. So, you know, I've always thought, you know, have the best of both worlds. You probably need two coils, as in a double burger. You know, a large loop and a small one. Now, you can do. I might as well tell a few people this, because you know, people are starting to get locked into detectors that you got to have a handshake coil and all this la-di-da stuff, you know. But what you can do, I'd say all the people out there making coils and experimenters, listen to what I say and do this. The detectors, the GPX series, the GP series, right, which are damn good detectors, right? They really are. You can do a lot of stuff to them. But you can do something really magic with the coil. You can make your own coil for it. Or if one of the manufacturers wants to do this and be first in doing this, why not? I'm not going to do it, so others can do it. Inside the detector, it has two receive channels, totally separate. If it didn't have the two receive channels, right, you can't do cancel mode, right? That's all it's there for. And in mono mode, it parallels the two receive channels together to theoretically get a 3 decibel improvement in signal to noise ratio on the receive signal. What I found with Minelab detectors, that doesn't work, and I had it proven to me by an ex-Minelab detector tester from many years ago. And what he actually did, he had a mono coil connected onto the detector, and he had a detector that was just barely breaking the threshold. I mean, a target which, with the coil going over it, was barely breaking the threshold of the detector. And he said, listen to this. And he was in mono mode, right? He gave me a listen. So I put on the headphones and I went over it. And I could barely hear it. He has much better experience than me. He was a guy who went prospecting every day for 30 years. So I'm not going to give his name away, but you know, he worked for a very big company for a while. Well, a retail outlet. I'll leave it there. And he said to me, "Now listen to this." And he flicked the mono switch into double D. Now, doing that on a mono coil, the other receive channel goes nowhere, right? We are now on just one receive channel. So the signal should diminish, or the noise should come up and obscure the signal with its own internal electronic noise. The signal came up, and I went, "What?" That's, this is very important, people. So there's me thinking the signal has increased by doing something that should not work that way. It should be completely the opposite. So what is the mechanism causing this? It's an unbalance somewhere in the detector circuit. And I'm suspecting that it's the way the network is designed around the 74HC4051 chip, which does the switching for cancel, double D and mono. Make sure if you ever play with that chip, don't put a 74HCT4051 in there. Put a 74HC. Trust me on that. So it's really, really interesting. So I had a bit of a play around with that, changing a couple of resistor values. I think it's 2.2 Ks, a couple of 2.2 Ks in that circuit, and I had to change them to 1.8 K. And lo and behold, I went from double D back to mono, and the signal went up. Right? This is my opinion that I measured on my oscilloscope, and that's my oscilloscope's opinion, right? So everything's an opinion. So my opinion is it wasn't designed properly in the first place. That's my opinion. Might be wrong. Might be something else. It's all very interesting. Detectors. There's so many things you learn when you know, repair these things, modify these things, build up sub-circuits, put them in, do all sorts of things to these detectors, and you learn a lot. Now, here's an interesting one too. This is for prospectors. If you're out looking for gold, all right, this is important as well. It's important, but it's also a little bit dangerous. And I'm going to say why it's dangerous. It's basically my disclaimer. Don't do dangerous things, people. But this is just a fact of life. And it's my opinion. With these detectors, right, I'm talking, I haven't really looked at the newer ones, but I've used the newer ones. I don't like them. I've purchased newer detectors and I sold them again, right? Don't like them. I'm talking about gold detectors. I had an SD2300. I borrowed a GPX 6000, bloody noisy thing. It's good on small gold. It's noisy. You won't hear deep signals, I'm sure. My opinion, as a someone who's been prospecting and using detectors for over 40 years. My opinion, right? And I'm gonna have another drink. But what I'm going to say, during the summer months, and you know it's not too cold and people want to get out and prospect, Go over an area, and you'll get, say you find a couple of bits, right? Okay. You then say, well, I'm going to grid that area and I'm going to rake it. Rake all the leaves, twigs, everything off, scrape the coil on the ground, and you'll swear black and blue, there's no more gold there. Okay. Go back at night. Dangerous. You might fall down a hole. You might die. You might walk on a snake. Um, whatever. But it was a big thing a while ago where people would get those LED headlamps and go out detecting, and lo and behold, more gold comes off the ground previously detected. Why is this? Now, there's been a lot of speculation. Lower atmospheric interference. Yes, the sun creates electromagnetic interference and it can affect metal detectors. The power grid crosses the country, and if you got everyone with, you know, doing things during the day, drawing power, you're going to get a lot more earth return currents, just leakage anywhere. It doesn't really matter. There's a lot of country areas that use that earth return power system, right? Whereas the return, you get two wires for your normal AC. Well, these things have one wire, and the other wire is the ground. It's the dirt. They put big metal stakes into the ground, and it's a earth return. What do you think that does to metal detectors, right? Anywhere near those systems, it will be causing all sorts of 50, or depends where you are, 60 hertz noise, 50 hertz noise. Depends what country you're in, that's what I'm saying that for. And it's a nightmare type thing. So at night, a lot of equipment is turned off. So there's a lot less earth return signals and so forth that really upset pulse induction detectors. But the other thing that changes, and this is more so, it happens a bit at night, and it's to do with the ground temperature, right? I've got a device that I actually broke the coil in it, which is, it's a scientific instrument, and it measures magnetic viscosity of the ground. You put ground samples in this thing and it can tell you the magnetic viscosity of the ground. I'll tell you some magic that I found. I have some samples. I did this a while ago because I've got to rebuild this thing. It's got a polycarbonate form of a coil on, a couple of coils, and it's basically broke in half, so I've got to fix that. My ground samples, I remember when I took the ground samples, it was fairly warm, and I measured them, I wrote them down in a book, and I was doing this in various areas just to work out the mineral content of the soil, how much ironstone, how much magnetite and so forth was in the soil. And I came back and retested these soil samples against some other soil samples in winter, and there was different readings. This is very interesting. So the magnetic viscosity of the soil changes, well, it does change over temperature. If you heat it up and cooled it down, yes, it does. But I didn't think it would be that dramatic from winter to summer. I didn't think 10 or 20 degrees difference would make a difference. Yes, it does, right? So the interesting thing is, when you go over the ground again, and I'll tell you what, my opinion, right, don't do this. But if you went detecting in winter, right, where it's freezing cold, in the middle of the night, you will probably find, more likely than not find, more gold where you have found gold before. Now, I know it sounds really strange, but you have everything working in your favour on cold ground. The other thing, too, people don't realise is that in these detectors, they're so damn sensitive, and even the carbon or graphite in the coil shielding, it in itself makes thermal noise. It just does. It's resistor noise. You can go look up on the internet. Go Google resistor noise, right? And I'm not going to go into the technical detail of it, but everything has noise with temperature. And when you're using a detector on a hot day, so you go out, it's 40 degrees Celsius, you know, 100 degrees Fahrenheit, whatever it may be, and your detector's getting the sun on the detector and the whole thing's heating up, your detector will not pick up faint signals as well if that detector was near 0 degrees, either freezing. It will work a lot better. The electronics in the detector is a hell of a lot quieter when it's cold, right? Now, a while ago I thought about putting Peltier cooling devices on the input stages of detectors, cooling them, right? It's feasible. You could do that. And then I thought to myself, what a bloody nightmare of a thing. Peltier devices draw heaps of current. You're probably going to be drawing another 3 amps. Your battery's going to go flat. But what you could do, if someone wanted to do this, I don't suggest doing this, but it's just an opinion, a thought. If you could make a heatsink block with some channels in it and with some tubing arrangement, circulate some liquid nitrogen through your detector, through tubing going over the front end stage. Now, if you want to know about this, years and years ago, I used to do satellite receive preamplifiers, and I used to do them for OSAT. We're using MGF 1402 gas FETs. Very, very what are they? 0.35. Yeah, something like that. Oh, it's a long time ago I did this stuff, but anyway, very, very low noise devices. And how we used to get an improved noise figure, right, is we used to freeze the whole front end block in the middle of the satellite dish. And we used to be pumped full of liquid nitrogen. So if it works on radio signals, especially satellite communications, to lower the noise floor and get a better signal, it'll work on detectors. So it's something to ponder about, isn't it? Like it sounds like a big thing to do, having a liquid nitrogen cooled detector, but it can be done, and it would be beneficial. The other thing too, if you could run liquid nitrogen through, say, a plastic tubing inside your coil, and keep coil windings cold as well, keep them very chilled. Or your other option, go out in winter. But this is really pushing it out there. This is like super scientific prospector time. But you would see a benefit. There's all these things you could do that would have a really good benefit on how the detectors perform. And this would be fantastic for locating big lumps of gold deep. You would have an edge. Where you just have the warbles of sound and you wouldn't know it was there. If you drop the noise figure down, right, and it's quiet, where the signal was in this warbly stuff here, I'm even talking on electron level, just the warbles of electrons, stray electrons, you know, and all sorts of thermal issues. And you drop it, and that signal was here. Now it's there. Before it was all covered. It's like a reef sticking its head out from under the waves. Same sort of thing. The waves is a noise. And if the ocean drops, well, look at that. There's a reef. Gone. There it is. Same with the noise. It's quite critical. So there's a lot of advancement that can be done in input stage switching. Get rid of the noisy MOSFETs on the input switching, which nearly all the pulse induction detectors have. There's a lot of things that can be done. Even a fully floating front end. I mean, fully floating, you could run very much the same as what that Gold Monster's got in it. You could have your whole front end floating. You could put your analog to digital converters on that, and you could then pump the whole thing from your floating front end down an optical fiber into the rest of the detector to be processed. No one's done it. Why not do it? So yeah, anyway, that's probably enough chat. It's pretty general, but if someone actually took 5% of what I said on board, your gold fines will increase. And if you did the whole lot, your gold fines would increase massively. But someone should really look at doing the two coil. Well, actually, what you really want to do, you could do two coil. You know, I was saying about the two coils. You could have one receive channel mixed in with the transmit, but you still got to have that flyback blocking FET input stage, which is noisy and lossy in itself. But what you could do is run a separate transmit coil, and on the receive lines, the two receive channels in, put a coil in the middle for small gold, and put a coil on the outside of the transmit winding for larger gold. But the thing is, because you're sort of over homogeneous ground, you're not going to get a lot of problems in the ground balancing between the two coils. You could also flip the phase of one of the receive coils too, and then you could have semi noise cancelling, because you haven't got this exact same diameter. It would be a semi noise cancelling, and something more reactive to the small coil will react with that, and something more reactive to the big coil will react with that. So you could actually use that as a way of discriminating, is it small gold or is it big gold? Now I've said all this, I would say one smart coil manufacturer will suddenly have the penny drop and manufacture 3 coils. See, to do it properly, you really need 3 core cable. You want your normal transmit, and you want another 2 insulated, shielded, spiral wound shielded cables for your receive. And you could have a real good play with that. You could probably even flick it around in cancel mode and change the phase on one receive coil to the other. So you can have 2 coils working in phase, flip it into cancel, still work as a mono, but it'll flip the phase of one coil. You might have to do a little bit with fine tuning and so forth, but can be done. It can be done. It will work. Anyway, that's enough waffle. I've given everyone something to think about. Oh, now I'm going to get up. get up out of this without killing myself and hit the Fireball whiskey. Catch us.